Okay, thanks, Marko. So good day to everyone and welcome to today's weather briefing. So as Marko told, I'm Petra Mikuš-Jurković from Croatian Met Service. I'm working as a forecaster, but my main interest is actually convection, especially forecasting convection using satellite data and also lightning data. So for the beginning, I want to ask you, where are you from? So can you please mark your destination on this map of Europe? Okay. Thanks. It's very nice to see that we have participants all over the Europe. So I'm from Zagreb, actually from the small village near Zagreb. But my office is in Zagreb. That is the capital city of Croatia. It's situated in central part of Croatia, so somewhere. Oops, not here. Sorry. But here where you have this cross. Okay, nice. So we have the participants all over the Europe, and now we can start also with the synoptic analysis for the Europe. So we will look at the weather situation. For the beginning of the analysis and also forecast, it's always useful to look at air mass RGB. Because on this RGB you actually get a quick look of the synoptic situation all over the Europe. So just look on one satellite image, you can define the area of warm and cold air masses. You can see the fronts, cyclones, maximum of PV anomaly. Also you can define the jet streams. So if we actually look at this air mass RGB from today, we can say that we do not have some very pronounced fronts or cyclones, but we can say that we have a lot of cloudiness across the Europe, and also we have some potential lows in the surface, so the center of cyclones. Also we can see on this air mass RGB. But let's start from the beginning. So now I want to ask you and please you to mark the borders between warm and cold air masses, which you can see on this. Okay, you are quick. Very nice. Yes, it is very nicely drawn, this border between cold and warm air masses. Just a minute, I want a pointer here. Okay, now you very nicely actually draw the border between this colder air mass, which is shown in these blue and blue purple colors, and the warm air mass, which is in this greenish color. And here we have something between these two air masses, so not so cold as this one and not so warm as this one here on the south. If we look at the model field of temperature at 500 hectopascals, we will see that this actually temperature very nice collocated with these air masses or on air mass RGB. So here is the cold air in this bluish color, here is the warm air in this green color, and here we have something between these two air masses, so not so cold and not so warm as this in south. If we also can see on this air mass RGB the maximum of PV anomaly. So now also I want to ask you to mark the maximum of PV anomalies on this RGB. Very nice. Yes, it is actually shown in this brownish reddish color, and we can nicely indicate this maximum of PV anomaly. So if we this overlap with the model data, okay, we define a lot of this. but this is for sure. 1, 2, 3. We have something here, yes, and here, here. I'm not sure for this one, but we can actually look at the model data and see how it look on it. So we see here that actually we have very nice collocation with this brownish color. Also, if you look at this PV anomaly, so we have one here, here, and you all of this PV anomaly very nicely marked on the satellite image before. So why is this important also to find? Because very often this PV anomaly is collocated with the center of cyclone or with upper level lows. So now we can look at the mean sea level pressure and see what we have at the surface. So here we have this low, the center of low pressure, also one here. Here also is the center of the low pressure. In this case, here we don't have this low pressure center, but we can check in the upper levels, and maybe here we have the upper level lows. But what we can see here that almost the whole Europe, especially here the Western Europe, the Central Europe, is under the influence of low pressure. So we can expect some cloudy weather with some rain or showers. The higher pressure is here on the more on the east. But here, if we go more to the east, here we have again the low pressure system. So we can say that today in Europe we have a pretty unstable weather with lots of cloudiness and some rain and showers. But as I told you, I want to also see what happened in the upper level. So if we look at the 500 hectopascals, we see that we are under the influence of very pronounced trough across the Europe, where we have some also cutoff low. One of these is here. The second one is here. We can also hear this cutoff low. And as I told you here, when we have the maximum of PV anomaly, we can say that also we have the upper level low, and this upper level low will influence on the weather here in the Baltic Alps and also in the western part of Europe, especially here in France, and can produce some instability, so some rain, showers, and even thunder. Here we also have one low, which can bring the which give the unstable weather here in Spain and Portugal. But what else we can see on the air mass RGB? That is actually the jet stream. So again, I want to ask you, okay, you already start, to please you to mark the jet streams. Yes, very nice. So these jet streams in air mass RGB is actually represented in this brownish, reddish color as these lines which you can see here. And you can always check with the model fields and see if this is nice overlaid. So we can do the overlays with the model field, and we can see that actually it's very nice collocated with this brownish reddish line on this air mass RGB. So you can see how this air mass RGB is actually a very strong tool for doing the synoptic analysis, because just on one satellite image you can get a very big amount of information, and you can actually have a quick, briefly look what will happen all over the Europe. So according to this analysis, we can say that a large, actually almost all Europe will have this not unstable, cloudy weather with some rain, with showers. But what I'm very interesting is if there will be some instability or some convection or maybe some intense thunder showers or thunderstorm. So let's look at the upper level and see what happened. So we have already analyzed this image, but let's go again because I want to now have some briefly overview on this area here. Why? Because here we have very pronounced southwesterly flow. So this southwesterly flow actually brings the moisture from the Mediterranean and also this warmer air from the Mediterranean and from the Africa here on this part of the Europe, so on the central southern Europe. And so we can maybe expect here some instability. And what is very nicely to see here is also this short wave trough. So very short wave trough, which is also one of the patterns suitable for convective initiation. During the day, the short wave trough will move more to the east and also can bring this instability here in part of Croatia, Bosnia, Serbia. So maybe here, according to this synoptic situation, we can have some convective initiation. But of course, we need to look at the ingredients which is necessary for the convective development. So we need to look at the model field now. Of course, so for the convective initiation, we need three ingredients, that is moisture, instability, and lift. And it is always very good to have the deep layer shear. It is not necessary for convective initiation, but it is necessary for organized convection. So if you have a large deep layer shear, you will have multi-cell, supercell, or maybe mesoscale convective systems. Here, if you look at the model field of Ecmwf, you look at the cape. Cape is this blue-green color, and deep layer shear is actually these contours, and you can see that we have some cape right here when we have this southwesterly flow and also this short wave trough, and also here where this short wave trough will move during the day. So if you look at the thunder case probability, you see some signals here in this part of Italy, in Croatia, Bosnia, and something in Serbia and Montenegro. So here we can expect maybe some instability, some thunders and thunder showers. So let's look what actually the different met services give for today. And if you look at the weather warnings in Meteor Alarm, for today, we can see that really the different met service actually give the warning for thunderstorms for today. So on this part of Italy, in Dalmatia, so in the coastal part of Croatia, here in Bosnia, and in Serbia. So it gives actually the yellow warning, not too strong thunderstorm, but maybe intense thunder showers that can potentially be dangerous. So according to this synoptic pattern and also some mesoscale analysis, we can give actually very nicely forecast and probability of thunder showers across the Europe. So as we see, today is very unstable across Europe, but the whole April actually was very unstable. We have these typical unstable spring weather conditions, where in one day we have a sunny and a rainy hours, but this April wasn't so typical in temperature because in Croatia we have very cold April, but Marko will tell you a bit later about that, so about the cold outbreaks. Now I want just to give you a few examples of unstable conditions over the Europe in this April. So we have some examples of air mass RGBs during the different days, where we have a very interesting synoptic pattern. So on this image we have this cyclone in the Mediterranean. Here we have the upper level low, one very pronounced cyclone with cold front. So all this actually give us unstable, cloudy and rainy weather in Europe this April. But now I want to actually go in more detail on this day. Actually, I want to show you the upper level low and the conceptual model of this upper level low. More about the conceptual model of upper level low and the other you can find also EUMeTrain web page in Satmanu. But here we will look at this upper level low on air mass RGB. It is always very nice represented with this brownish reddish color. So one of the key parameters is of course high contrast at 500 hectopascals. So you have these closed lines. And also the temperature at 500 hectopascals when you have actually this minimum of temperature, because the upper level low is always colder than the surrounding. So here you can very nicely see that that actually is represented brownish color on air mass with this minimum in temperature, and also in this minimum in actually in this closed high contrast at 500 hectopascals. Instead of this one, we have also this one here, upper level low, and also one here. But we will look in more detail just this one here. Again, what our upper level low is very nicely seen also on the water vapor 6.2 micron satellite image. So here you can see this cyclonic curvature, and here is also one. Here is not so pronounced, but maybe if we actually animated these water vapor images, we can see something like cyclonic curvature. So this is another satellite image when you can see the upper level lows. And another key parameters is of course high contrast at 100 hectopascals and potential vorticity when at the surface. So at 100 hectopascals you do not have these closed lines, so you do not have this surface low, but just low at the 500 and 300 hectopascals. And here, of course, you have the maximum of potential vorticity. Again, we can see also a typical vertical cross-section of this upper level low. So we will done the cross-section right here, and you can see that the cold advection is ahead of the upper level low, the warm advection is behind it, and also you have the maximum of potential vorticity. So the parameters which is typical and shows the typical structure of upper level lows is actually the temperature advection and this potential vorticity. Another actually example, which I want to show you, is the 20 April 2021. Why? Because we have here in Croatia influence of two systems, synoptic systems. One is cold front, which is associated with this pronounced cyclone, and the second one is warm front. And that was actually the convective day in Central Europe. So according to this synoptic situation, I want to ask you, where will you expect some convective initiation? Just look at this synoptic situation and this synoptic pattern that you have here. Yes, that's very good. Yes. Okay, nice. Yes, we can expect some some convection here at the leading edge of the cold front. Why? Because that is one of the typical synoptic environments for the initiation of convection, and more about that also you can find on the EUMeTrain web page. But why is that so? Because we have actually the temperature gradient, and also we have the usually warm air near the surface, cold air ahead of the warm air, and then we have the convergence also near the surface, so some actually mechanism for the lifting of this unstable air. And that day was one of the first days in April when we issued the yellow warning for the thunder showers in Croatia. So we can see here on HRV, we have some convective clouds here, but it wasn't so intense. Yes, it produced some showers, it produced some thunder, but it wasn't so severe. So if you look at the convection, you can look at the HRV satellite image because you have very actually you have bigger resolution, a resolution of 1 kilometer, and you can look at the sandwich product because sandwich product actually gives you two information very important on one image, so about the structure of the convective clouds and also about the temperature of the convective clouds, of the tops of the convective clouds. Also, if you have some severe convection, you can look at the convection RGB. It's also useful for observation of convection, and more about this convection RGB you can find on the EUMeTrain web page in the RGB quick guide. So I encourage actually you to look at this RGB quick guide because it is very, very interesting and very nicely structured. Okay, and now I just for the end of my presentation, I want to say that April, as I told you before, was colder than usual, especially in Croatia. If you look at this image, there was 2.5 degrees colder than usual. So usually we have such grumpy people that do not like that kind of weather condition in April, but Marko now will give you some example of this cold outbreak. So Marko, now the floor is yours. Go ahead.
Thank you, Petra. I'll just shift over and upload the presentation. Okay, so thank you, Petra, for this introduction. I will now continue with this extreme beginning of spring that we had here in Croatia. And now one actually question for you before we actually start with those extremes. So here on this nice natural color RGB on 1st April at 12 UTC, when I opened it, I saw some things which puzzled me, and I'm asking you now to actually give me some answers to what do these things represent. So I want to ask you, what does this area, you can see that this area over the sea is quite hazy in, let's say, in comparison with the Mediterranean or the North Sea or the Atlantic. So what do you think, what is going on here under area A? Do we have some clouds or something? What is here under the letter B, and what is here under letters C and D? I'll give you some 10-15 seconds. You can use the text tool from the annotation tools and write something on the right side of this slide. I already see some answers, some ash, some snow. Okay, yeah, B is, well, quite obvious. Snow in mountains, in the Scandinavian mountains. Okay, some more ash, dust, good. Under sea we have ice. D is pointing to this bluish phenomenon in Lake Ladoga. So, if you're wondering what D is actually asking about. But anyway, I can see many answers already. Yes, under A, we have dust, ash, dust, ash. Yeah, well, basically you were quite close with ash and actually correct with dust. We will come to that a bit later, just actually in the next slide. Under B, we have snow in the mountains, and C and D is actually sea ice and lake ice. Okay, thank you for your answers. And here in this 24-hour microphysics, we can see that this dust outbreak that was at those days came from Sahara somehow, here over France, over Great Britain and Ireland, possibly due to this cyclone, but also possibly because of some cyclones before. We also see one dust outbreak here in Morocco and Algeria. So this day we see that the weather was quite nice in most of Central Europe and in France, in Germany, in Croatia, many, actually very little clouds. We see some fronts, cold front here, some clouds here because of the lows that we will see in the next couple of slides. And as I said already, this cyclone here that is actually filling up. It is an old cyclone and actually quite a high pressure, and it is filling up, and it will not be actually very important for the future, actually for this weather briefing in the next slide. This front also is not very strong. It is it's a remnant of an older cyclone that came something from here, and basically this is just a remain of that old cyclone. If we plot then the model fields over this 24-hour microphysics image, we can see some things that then explain us the image. Actually, we can see this trough here that is actually producing this cloudiness and actually going from northwest down to southeast and pushing this front more to the southeastern parts and eastern parts of Europe. So in the next couple of days, actually in the next day, the temperature, which is now at 850 something, about 10-12 degrees, will drop by several degrees because of this front. Here we can see the lows at 500 HPA that are affecting the weather above Portugal and Spain here, and the weather above Turkey, Greece, and some in Georgia and other countries in the east. As I said, we have some dust here and here. And if we check the Synop observations, why I actually picked up this date, the first day of April, I remember that day it was very, very warm for that part of the year, that part of April. You can see the temperatures here, 23, 22 in Croatia, 21 France, 23 France, 16, 18, 23 Germany, etc. So very warm weather, temperatures, very nice weather with very few clouds above large portions of Europe. And actually in Zagreb we had actually something like 26, even 27 degrees in some places, which is extremely high for that part of the month and actually the season. So that is one extreme that we have covered here. Basically, this ridge affected that extreme. It brought nice weather. It brought warm air from the south, and then the temperatures rose before they will fall in the next couple of days, and we will see that now very soon. So I have marked here Zagreb 26 degrees centigrade maximum temperature for the day. This is the air mass RGB that you know very well. We see here again these structures, the cyclones, this convective, very convective area over, actually under this upper level low. The trough and the ridge, which the trough is then pushing the ridge away, and we will lose this very nice weather in actually the next day already in Croatia. And then if we go 2 days forward, we can see how a trough has arrived from the north, brought rather cold temperatures around. If we check now here, we have something around -1, -2 degrees at 850 HPA. And if we add those 15 degrees, that is in some ideal case and some ideal weather that we usually use with 850 HPA temperature, we get some 13 degrees centigrade, which would be some kind of a forecast, and exactly that was the maximum temperature in Zagreb that day, which was, well, quite more normal for that time of the year than those 26, 27 degrees that we had 2 days earlier. So again, quite strong jump in 2 days from 26 to 13. But then as we go forward, we can see actually that there is something going on here. And there will be actually a trough and a very cold intrusion from the north that will come in the next day and the next couple of days to central and southern parts of Europe that will affect it in a very specific way. Here, with the passing of this trough, we can see how the gradients of pressure shifted, actually how they look. We can see that there is a lot of northeasterly wind, a rather strong wind. We had also some episodes of Bora because of that, because of this difference in pressures in between the continent and the sea, and also the temperatures. While here in the central parts and eastern and northern parts of Europe, the weather was quite bad. We can see that actually here over Great Britain and Ireland, the weather was under the influence of the anticyclone, and it was rather nice also here above Egypt. And then 2 days later, on 5th March, we see the arrival of this really nice big ridge trough, with the very cold air mass coming from the Arctic, and this very nice example of cold front. We will come to the front a bit later. This day in Croatia, we still were under the influence of this rather weak ridge, which secured a rather nice weather with some temperatures at 850 HPA, around 1 or 2 degrees centigrade, which then resulted in 17 degrees maximum temperature in Zagreb. But this ridge will very soon be pushed away to the southeast and east by this very big, very strong front, which is a part of this very big cyclone in the north over Scandinavia. If we check the mean sea level pressure, we can see again very strong gradients of isobars, very strong winds over the sea and over the country from the northwest, and in front of the front a very nice southwesterly flow, which actually then also brought some heat to the two parts of Croatia, and because of that we had those nice 17 degrees on this 5th April day. Now this is quite a busy slide, but I wanted to just present this front and some of the key parameters. I was suspecting it was an ANA cold front, and I was actually, my thoughts were confirmed with checking some of these elements in these fields, model fields. So basically we have the isotachs going parallel with the front, and inside of the front the thickness gradients are also inside of this cloudiness in the green isolines, and as you can see as well, the blue isolines and contours is the very strong cold advection that is also located inside of the frontal cloudiness, which is very typical for the ANA cold front. Again, about the front a little bit, I've pulled a vertical cross section, and inside you can see the cold front, the surface front, and the elevated front as well. In the temperature advection, you can see very strong cold advection in the front, and above the front, actually a bit behind it, you can see quite strong jet streak, actually core of a jet stream, and the winds that reached about 55-60 meters per second. One view of the front and the situation from the natural color RGB. You can see how the front is looking in the natural color RGB. The icy part of the front, actually the top of the clouds are icy here, something like mixed cloud phase here, and some watery clouds over France and into the ocean. Here in this area you can also see very nicely the open Rayleigh-Bénard cells, which are very characteristic for the cold air behind the cold front, especially over the sea, because over the land the friction and the low humidity is not very good for their development. And now the day after, 6 April at 12 UTC, we can see after the front passed, it brought with itself very cold air. Basically, the temperature at 850 HPA fell to around -8 degrees centigrade over Croatia, and because of that, also because of the wind, because of the cloudiness and everything, we cannot actually just use those +15 degrees to the temperature at 850 to get the maximum daily temperature, but that day the maximum temperature in Zagreb was only 2 degrees centigrade and for April that is quite low. Also, there was a lot of precipitation in that day, as you can imagine, from those 17 degrees the day before, a lot of warmth, a lot of humidity, and then the front crossing with all this cold air. And also you can see here many convective cells, yes, with showers, precipitation, and snow showers, rain showers, and other. As I said, I just put now here again the 24-hour microphysics RGB. and there is no 850 HPA temperature here, but I've put the synop observations here, and you can see snow, rain showers all over the central parts of Europe. Even here in Croatia at the coast, we had strong snowfall, and basically the whole continental part of Croatia got a lot of snow that day, as well as the rest of the Central Europe, I believe. Something shortly about that. Basically, they said that was a very, very cold air intrusion, and in Croatia we had some new April records. So as you can see, for these here places, the records were broken. For Gospić, which is here, we had on the 7th of April minus 12 degrees, Delnice here, Ogulin here, Karlovac, Bednja, Zagreb, and even in Rijeka on the coast we had minus 1.2 degrees. This is a picture taken from the Croatian radio television website. And snow height as well was the records of that were broken for actually many places near the coast. So, for example, Knin, Sinj, Imotski, and Šibenik. Even at the very coast, at the sea, we had 1 centimeter of snow. Unfortunately, also the temperatures at 5 centimeters above the ground were very low. So, for example, in Gospić, where we had minus 12 on the 7th, the temperatures at 5 centimeters dropped to minus 17, and that was not very good for the vegetation that already started to grow and bloom and everything. So there were also quite big damages in that area. So let's shift a bit to another topic. Which channel of the RGBs? This RGB is mainly responsible for the yellow signal. I will answer that for you. It's the 3.9 micrometer channel, which you probably know very well. And actually, what do the two distinct yellow signals mean? What do they represent? And the two yellow signals are these three and these two. Can you tell me in the chat, maybe right on the screen if you like, what do they actually represent? Why is in the Central Europe, why do we have yellow signals there? And why do we have yellow signals above the Mediterranean and Asia, Turkey, Iraq, Syria? Do you have any ideas? Yes, that is true. That is actually the reason why we have the yellow signal. But do you maybe, so basically very small ice particles. But do you maybe have an idea why do we have very small ice particles? Wave clouds, yes, exactly. So yeah, we here in central parts we have, as we had the model fields before, we have southwesterly flow, and then the wind is flowing, the air is flowing above the mountains, as you can see on the next image. Actually, you have in the HRV clouds RGB very sharp edges of clouds, which can mean well, only one thing, basically, that we have some lee cloudiness, and because the air is rising very suddenly across the above the mountains, the clouds that are produced have very small ice particles that reflect a lot of radiation in 3.9 micrometer channel. Here, I'm not sure, dips, this is, I believe, dust that you have answered. I'm not sure the whole abbreviation dips, what does it mean, but if you meant dust, yes, you are correct. and basically these clouds and these systems pulled in a lot of dust from Sahara, and again, a lot of condensation nuclei made a lot of small ice particles that then reflect a lot of sunshine and actually radiation, and because of that we have a big green component which mixes with red component and gives us this strong yellow signal. Now just very shortly for the end, I know it's already late, but very shortly, just about the St. Vincent Le Soufriere volcano eruption, 10 April. I've checked that it looked very nice in the satellite images. In this 24-hour microphysics RGB, you can see really nicely this ash cloud in very pinkish magenta colors. Unfortunately, I didn't have the ash RGB on ePort when I was checking that, but the recipe is basically the same, so we can check the eruption with this RGB as well. Then I saw these stripes away from the volcano, and I wasn't actually sure what that was. I was thinking that this is an SO2, that were an SO2 clouds, but they were in this strange form, in the form of stripes, not in the form of a single cloud or something like that. But then I checked the air mass RGB, and there you can as well see these stripes in a bit larger clouds of red color, which basically means because of this 7.3 channel that this is SO2, because SO2 at that band is emitting very low. So in conclusion, in this difference, then the difference is high, and because of that, we can see a lot of red color in the SO2 clouds, from the SO2 clouds. Just a view then again from the cloud face RGB, the new RGB that will be available in the MTG. The smoke is very nicely seen from the volcanic eruption in some kind of yellow-green color. So basically these two, 1.6 and 2.25, are working together. And on the cloud type RGB, we can actually see that this RGB is not good for these this type of analysis, because it is this eruption, the smoke cloud from the volcano, is not visible almost at all, because we can see this pinkish clouds all over the place as well. So it is not very clear that this is actually a volcanic eruption. So that would be it from me as well. Thank you for your attention. I'm sorry for this weather briefing being a bit longer. The next weather briefing will be held on 28 May, and it will be held by our colleagues from SANC. Thank you again, and if you have some questions now, feel free to ask.